Alright, number 13. G of x equals x squared plus 2, so find g of negative 4. So they're asking you to replace what with what? They're asking you to replace the x with a negative 4 in this equation. So x squared plus 2, but instead of x, they've told you to replace x with a negative 4. So g of negative 4, if the input's negative 4, the output is it's 18. Okay, I need you all to be quiet so you can listen. Guys, doesn't negative 4 squared mean negative 4 times negative 4? Which is a positive 16. However, I know what all of you did. You did not put that negative 4 in parentheses before squaring it. And your calculator reads this as basically a negative times a 4 squared. That's how your calculator is reading that. It is only squaring the 4. It is not squaring the negative. To get your calculator to square, see, like, it doesn't even understand that part. To get your calculator to understand that you need to square the negative and the 4, you need to put it in parentheses. And then your calculator knows that you're squaring the negative and the 4, which will give you the positive 16 you were looking for. And then when you add 2 to that, you get 18. Does everybody now understand? Anytime you plug a negative number in that calculator, you better put parentheses around it. Anytime you put a negative in there, put parentheses around it. Alright, number 14. F of n equals 4n minus 1. Find f of 4. So they're asking you to do what? Right, replace the n with a 4. So in this equation, 4n minus 1, they're telling you to replace n with a 4. And so when we do that, f of 4 will equal 15. When your input was 4, your output was 15. Now, number 16 is a little bit different because this time, did they ask you to replace x with a number? No, they said leave x as itself. So the negative x plus 5 stays. They're asking you to replace the wx with what it's equal to, 11. So now what do we do? Subtract 5. And so you get 6 equal to negative x. And then what do you have to do to solve for x? Right, that's a negative 1 that you must divide by on both sides. And so x equals negative 6. Okay, now let's go down to number 21. K of x equals x plus 1. So find k of x equals 6. Look, x stayed x. They're not asking you to substitute anything for x, are they? So it stays. What they're asking you to change is k of x. They're letting you know what it equals. It equals 6, so instead of writing k of x, we will write 6. Yes? Okay, remember that property we learned called the transitive property? Okay, this is what, don't write this down, just pay attention. This is what the transitive property said. It said if A equals B and B equals C, then A equals C, right? Think about it. If they're both equal to B, then aren't they equal to each other? So now let's apply that with what we have in this problem. If k of x equals x plus 1 and k of x equals 6, doesn't that mean that 6 and x plus 1 are also equal? And by doing that, you've made yourself an equation that you can actually solve for x. And how do we solve it for x? And so you get x equal to 5, which makes sense because look, if your x value is 5 and you plug a 5 in for x, is it 5 plus 1 equal to 6? Sometimes they're wanting you to replace the variable in the problem, and sometimes they're wanting you to replace the overall answer it's equal to. Okay, number 24. F of x equals negative 2x plus 5. Find f of x equals 19. Same thing. It's the transitive property. If f of x equals negative 2x plus 5 and it equals 19, doesn't that mean negative 2x plus 5 also equals 19? Because they both equal f of x, so they must equal each other. So now to solve for x, what do we do? And so negative 2x equals 14, and then we divide by negative 2, and so x equals negative 7. Okay, now that I feel like you have a better understanding, now retry 25. Okay, look, Joseph, I don't want to write h of a, okay? So instead of rewriting h of a, what could I replace it with? 16. And why am I able to replace h of a with 16? Because they're equal to each other. It's like a substitute. Since they're the same thing, they're equal, you can use one in the place of the other. So now what do I do? Now I need to solve for a.
Yeah, I get all that. That part right there is just. I'm just saying, sometimes you can say replaceable A or replaceable H, but at the same time, replaceable 16.
Right, so a equals 4. Okay, turn to the next. A function f had the following input-output values. See how they gave you a table with input values and output values? Write an equation to define the function f and use it to find the output when the input is negative 9. So this is a two-part question. The first thing they want you to do is write an equation. So y equals. How in the world are they getting from the input to the output each time? Now keep these things in mind. Input are your x values. Output are your y values. So Anna, what do you think they're doing each time to get from the x to the y? Very good. Think about it. If you take your x value each time and divide it by 3, isn't 5 divided by 3 5/3? And isn't 4 divided by 3 4/3?
Yes.
And if you plug in 3 and divide it by 3, won't you get 1? So that is the function that represents this table. So now here's the second part of that question. If they tell you an input is negative 9, so I'm going to add an extra input in my table, how can I find the output?
Divide it by 3.
Divide it by 3 and you get negative 3. Okay, number 2. John was given the following input-output table by a friend. Write a function for the pattern in the table. So y equals what? 0. What is that called? What we did one like this the other day where they gave us an input to plug in, but there was nowhere to plug it in. A constant function. Constant. Because think about it. It didn't matter what input they gave us, wasn't output always 0? So if you wanted to, you could write it like this, 0x, because think about it. No matter what you plug in x, if you multiply it by 0, aren't you going to get 0? But really, it's just y equals 0. Because do we normally write the 0x? No. Okay, to find a function rule for a linear pattern, you're going to use the slope along with one of the input-output pairs in the pattern to determine the y-intercept. Then write the rule in slope-intercept form. Okay, luckily for y'all, for the rest of this worksheet, they've already given you the function. You have to use the function to complete the table. Okay, which is easier in my opinion. Okay, so remember what I said, input values are also known as x values. And output values are also known as y values. So first, let's deal with these two input values they gave me, 2 and 6. Think about it. If 2 and 6 are input values, aren't both of them x values? So can't we just write this equation 2 times, but each time in the x place, can't we replace it with those numbers? Okay, my first x value they gave me was a 2. My second x value they gave me was a 6. So now I need to find out what y equals so that I can fill in the y column. What does the first one give me for y? 1. What does it give me when I input 6? Negative 3. Okay, so those are easier than what we're about to do. Because now look, they've given me the output value and I need to find the input value. Well, the output value is the what value? So don't I need to take this -1 and put it in the place of y? So won't that become -1 equals -1x plus 3? Okay, so see how this time I rewrote it, but in the y place I plugged in a -1 because that's a y value. So now what do I have to do to get x? Subtract the 3. Correct, that'll give me -4 equals -1x. And then what do I do?
Divide by -4.
Divide by -1. So when when your output was a -1, what was the input? A +4. And you can always quickly check it. Look, if I plug in a +4, 4 times -1 is -4, and -4 plus 3 is -1. So it works. Right. You'll start.
How'd you figure that out?
Okay, number 4. Let's continue. This time we're doing the exact same thing, but instead of a table to represent the relation, they just gave you a list of ordered pairs. So in this first ordered pair, what value did they give you, the x or the y? The x. So doesn't that mean we can just take this equation, but instead of x, we can fill it with a 0? And now just type that in and you'll know what goes with it. 5. Because 2/3 times 0 is 0. 0 plus 5 is 5. Okay, but look at the next ordered pair. This time they gave you the y value. So doesn't that mean that when you rewrite this equation, you have to replace the y with the 7? So now for this one, we can't just evaluate, we have to solve. How do we solve it? So 2 equals 2/3 x. Now what do we do?
Multiply by 3.
Good. You can, listen to my voice. You can divide by 2/3, but like Genesis said, I taught y'all that when you're dealing with a fraction, it's better to multiply by the reciprocal on both sides. But you can divide by 2/3 if you want. Now, the reason we multiply by the reciprocal is because, look, won't that 2 and 2 cancel each other out, and the 3 and the 3, leaving x by itself like we wanted?
Yeah.
And now what is 2 times 3 over 2? 3. Think about it, guys. Isn't that a 2 over 1? So that becomes a 6 over 2, which is 3. So whenever your output was 7, your input was 3. Okay, let's look at the next one. The next one gives you the what value? The x value. That 6 is an x value. So you rewrite the equation, but this time it's the x that you're replacing with the 6. So evaluate that and you'll know what goes there. Guys, what is 2/3 times 6 plus 5? 9. Okay, and then in the last ordered pair, they give you the what value? The y value. So can't we just replace the y with an 11? So 11 equals 2/3 x plus 5. So to solve for x, what do we do?
You have to subtract 5.
And that gives me 6 on the left, 2/3 x on the right. Then what do I do? And so those cancel each other out, leaving x by itself, and this becomes 9. And then look, you can also look at the pattern. 0, 3, 6, 9 for your x's. Your y's were 5, 7, 9, 11. Okay, next page. I want you to, or actually we'll do this one together. Given the function, complete the table. So this time your function is the square root of x. This one's already been done for you, so we need to go to this one. This one is a what value? An x value. So can't you replace the x with a 1? And what is the square root of 1? 1. Okay, what's your next x value they gave you? 9. So what, you replace the x with a 9? And what's the square root of 9? 3. Okay, now for the others, they gave you the output. They gave you the y values. Well, for you to be able to have an output of 2, what was in here? A 4. And for you to have been able to have an output of 5, what would have had to have been in there? 25. The square root of 10 is not 5. The square root of 25 is 5. So we have y equals x plus 1 squared. Okay, well the first x value in the mapping diagram is already taken care of. It has an arrow going to 1. The second one is negative 1. So wouldn't we replace the x with a negative 1? No.
Squares.
Negative 1 plus 1 squared. So that's 0 squared, which is 0. Then what do we replace the x with next? Well, that one's already taken care of, see? So 3 is the one that has a missing output. 3 plus 1 is, 4 squared is 16. Okay, turn to the next page. Okay, I want you to take a second and try 2 and 3 by yourself. Number 2, use a function for the pattern shown. Okay, like I said before, the input ones are the easiest because you just plug them straight into the x. So like for this one, 1/4 times 0 plus 1 equals
1.
1. 1/4 times 2 plus 1 equals 1.5. But then the outputs are not as easy because you have to put 1 1/4 in the y place. So 1 1/4 equals 1/4 x plus 1. So what do I need to do? Subtract 1 on both sides. What's 1 1/4 minus 1? 1/4. Now to solve for x, what do I do?
Multiply by the reciprocal.
Right? Turn or sit down so they can focus. So look, those cancel, leaving x by itself. And what is 1/4 times 4 over 1? 1. And then, guys, what's that last input going to be? 3. All right, now let's go over number 3. Use a function for the pattern shown in y equals 3x minus 1. So, y equals 3x minus 1. Y equals 3x minus 1. I wrote it twice because I have 2 inputs to plug in, a negative 4 and a 3. When I input negative 4, what is my output?
Negative 11.
Negative 13.
My bad.
When I input 3, what's my output? 8. Now, the other ones are not so simple because you have to replace the y with a negative 4 and a 20. So, negative 4 equals 3x minus 1, and 20 equals 3x minus 1. See how I rewrote this equation? But in the y place, I put the 2 y values they gave me. So now to solve these, I have to solve for x. So on both of them, you add 1, right? On both of them, you're going to do the same steps. So for this one, you get, I'll just finish this one. So x equals negative 1. And for this one, now that you've added 1, you divide by 3 and you get 7. Your homework is to do the next page, page 36. There are 6 problems on it. Okay?
I have a very good question.